Hello everyone, welcome to this tutorial on automating the creation and rotation of Amazon SES SMTP credentials. My name is Gautam and I have Rakesh and Srinath here with me. We are all from AWS and we are excited to walk you through implementing automated solutions for Amazon SES SMTP credential rotation. Before we begin, I'd like to acknowledge the original authors of this solution, Zip, Jesse, Brett and Rob, whose excellent work on the AWS messaging and targeting block forms the foundation of today's demonstration. Let us walk you through what this blog offers. This blog post presents three approaches for managing SES SMTP credentials, each designed to address different use cases and requirements. Option 1 is a fully automated solution that leverages AWS Lambda, Secrets Manager, and Systems Manager. This approach automates the entire credential rotation process from creation to deployment across your email servers. It's built around AWS Secret Manager's rotation functionality and uses Systems Manager to automatically update credentials on your email servers. Option 2 provides a semi-automated approach, combining AWS Lambda and Secrets Manager for credential rotation while keeping your server updates manual. This solution is particularly useful when you need to maintain direct control over your email server configurations or when automated server updates aren't suitable for your environment. Option 3 presents an alternative approach by migrating to SES Mail Manager and using authenticated ingress endpoint, which supports either a standard SMTP password or AWS Secrets Manager. In today's demonstration, we will be focusing on implementing options 1 and 2, walking you through detailed implementations of both automated and semi-automated approaches. These implementations will give you a solid foundation for setting up credential rotation in your own environment, regardless of which approach you ultimately choose to adopt.
Let's examine the architecture for both options in detail. For option 1, which is the fully automated solution, the process begins with AWS Secrets Manager, which initiates the credential rotation either on a defined schedule or manually. This triggers a Lambda function that creates new SES SMTP credentials, validates these credentials, coordinates with Systems Manager to update the email servers, manages cleanup of all credentials, and with AWS Systems Manager, through its agent on EC2 instances, handles the secure update of credentials across all email servers, thus providing complete automation without any manual intervention. For option 2, which is the semi-automated solution, this architecture shares the initial components with option 1, but is designed for environments that require more control over server updates. The workflow starts similarly, where AWS Secrets Manager initiates the rotation, Lambda function then creates and validates new credentials. These new credentials are then stored securely in Secrets Manager. The key distinction is in the final step, that is, instead of automatic deployment, the credentials await manual implementation on your email servers. To support this workflow, Amazon Event Bridge monitors for successful credential rotation. When detected, it triggers an Amazon SNS notification. Administrators then receive alerts about the new credentials, and manual updates can then be performed at the appropriate time. This approach is particularly valuable when your environment requires manual control of server configurations, updates need to align with maintenance windows, and security policies require human oversight of credential changes. In summary, both architectures effectively handle credential rotation while offering different levels of automation to match your operational needs. For our demonstration, we are using an EC2 instance running postfix, though any SMTP compatible email server would work. We are operating within the SES sandbox mode, which is perfect for testing, but in the sandbox mode you can send only to verified email identities and are capped at 200 emails per day. Our setup follows the configuration which is outlined in this blog's CloudFormation template. The EC2 instance is configured with outbound access on port 587 for SMTP traffic and has an IAM role granting necessary Systems Manager and SES permissions. We have also installed the SSM agent on the instance and tagged it with the key email server and value true. These tags are critical as they are how Systems Manager identifies which servers to update during the credential rotation. We have also ensured AWS CLI access and the right permissions for services like CloudFormation, Lambda, Systems Manager, Secrets Manager, and SES. While this setup suits our demonstration, remember that these principles are flexible. You can adapt them to various environments, whether you are working with different email servers outside the SES sandbox or even in hybrid cloud on-premises setups. Now let's dive into the implementation of option 1, which is the fully automated credential rotation solution. I'll first log into my AWS console and navigate to Cloud Shell. I want to highlight that you can use any IDE with AWS CLI configured, but in this demonstration, I'm using AWS Cloud Shell. So to begin, let's first clone our repository containing the automation scripts. I will run the git clone command, specifying the SES credential rotation branch. As you can see, the repository has been successfully cloned. Let's change into the automatic rotation directory and examine the README file to understand our implementation steps. This README file provides a detailed guide of the steps we'll be following. It's a great resource to refer back to if you are implementing the solution in your own environment. You can also find this information on the GitHub repository page. Our first task is creating an S3 bucket in EOS East 1 to store our deployment artifacts. Next, we'll package our CloudFormation template. This process uploads our Lambda functions to the S3 bucket we just created and generates a new template with updated references. We can also see the CloudFormation package exported as an object in the S3 bucket here. Now comes the crucial step, which is deploying our stack. I'm running the CloudFormation deploy command with several important parameters. We are specifying our stack name, the necessary IAM capabilities, and various parameters including our email address for notifications and the tags that will identify our email servers. While our stack is deploying, let me show you our EC2 instance configuration. This instance has been pre-configured with postfix and the necessary SES permissions. Notice the tags we have applied. Email server true. These tags are crucial as they allow our automation to identify which servers need credential updates. The instance has a Systems Manager role attached, which enables automated configuration updates during the rotation. With our EC2 instance properly configured, let's return to our deployed stack and examine the resources it created. So this is the IAM key created as part of the CloudFormation template, which we are going to rotate in the next step. Let's test our automated rotation process. I'm navigating to Secrets Manager where we can see our secret. Notice that the rotation configuration is set for automatic rotation every 30 days. However, this interval can be customized based on your security requirements. While the automatic rotation will happen according to the schedule, for our demonstration today, I will bypass the waiting period and trigger a manual rotation by clicking Rotate Secret immediately. Let's look at the IAM console now after the rotation. You can see the new access key here that was created 1 minute ago. Now let's monitor the rotation process in real time. I'm navigating to our Lambda function in the AWS console. Here, I'll click on the Monitor tab and then select View CloudWatch Logs. Let me open the most recent log stream so that we can see the latest rotation activity. As we look at these logs, you can see the rotation process follows 4 distinct stages. Let me walk you through each one as we see them in the logs. First, we have the Create Secret stage. Here in the logs, we can see it generating new IAM credentials. This is the first step in our rotation process. Scrolling down a bit, we come to the Set Secret stage. Notice how it's updating these newly created credentials in Secrets Manager. This ensures that our secret storage is always up to date. Next, we have the Test Secret stage. This is a crucial step where the function verifies that the new credentials work correctly with SES. Finally, we have the Finish Secret stage. In In this last step, the function updates our EC2 instances with the new credentials and removes the old ones. This completes our rotation cycle. Looking further in the logs, we can also see a message showing that the old IAM access keys for user SES secret IAM has been successfully deleted, which confirms that the cleanup of all credentials has completed successfully.
Now that we have seen the fully automated solution, let's explore option 2, the manual credential rotation solution. This approach is particularly useful when you need more control over the rotation process or when automatic updates aren't feasible in your environment. Since we have Cloud Shell already open, let's navigate to the manual rotation directory in our clone repository. Looking at the README file, you will notice the key differences in this implementation. While option 1 handled everything automatically, option 2 provides a more controlled approach with manual confirmation steps. Let's start by creating our S3 bucket for this implementation. I'll use a different bucket name to keep our solution separate and package and store the Lambda functions here. Checking the S3 bucket, we can see that the uploaded artifacts are in this S3 bucket. Next, let's deploy our CloudFormation template. The command structure is similar to option 1, but notice the different parameter set. For deployment, we are specifying parameters that include our notification email addresses and IAM user settings. While the CloudFormation stack is being deployed, you will receive an important email. This is an SNS subscription confirmation email, and it is crucial to click the confirmation link in this email. This will enable the notification system for our rotation process. I see the stack being deployed successfully now. With the stack now deployed and notifications confirmed, let's add our server as an item to the DynamoDB table. This tracks our server inventory. So we are doing this by creating an item and adding the value of our instance ID against the attribute name. Navigating back to the IAM console, we can see that we have one access key. Now we can go back to Systems Manager parameter store where the SMTP password that is derived from the IAM secret key is being stored. We can see this under the show decrypted value here. So now let's examine the step functions created as part of the CloudFormation package. To start the rotation process under the step function, let's click on the Start Execution button and start the execution with an empty JSON object. We can immediately see the workflow begin. The green highlighting shows the current step in the process, and you can watch it progress through different states. This visual representation provides clear visibility into the rotation process. As you can see below, we are at the manual confirmation stage now. And looking at the manual confirmation step function, we are waiting on the credential change request for which we should have received an email notification. This email requests us to update the credentials from System Manager parameter store on our servers and then click on the email confirming that the change is done. So back in System Manager parameter store, we can see that the SES secret value shows version 2 of our credentials. This indicates that the new values have been stored now. We can also verify this in the version history here. And in IAM console, we can see two access keys now. This is expected during the rotation process as we maintain both old and new credentials during this transition period. Assuming we have updated the keys in our email server, I will now manually go and click the confirmation link in the email notification we received. As we can see the confirmation message here, this confirmation triggers the next phase of our rotation process. So back at our step function console, we can see the manual confirmation execution has succeeded. Next, we go to the credential rotation step function and refresh the state machine to check the events. As manual confirmation execution is succeeded, Now we see it's entered the wait state, specifically wait a day to check the confirmation. This visual workflow shows us progressing from creating the new access key for SES user through to its final stages where it waits 3 days before deleting the old access key. We have walked through both automation options for creating and rotating Amazon SES SMTP credentials. We hope this walkthrough helps you implement the solution that best fits your environment. For more details, including the specific blog post this video is based on, please check the description below.